react. You whispering my name, thinking I won't be the same. Turn fiction into fact. See what you didn't know, bruises that I'll never show, slipping on your every jab. So tighten up your fist, step into the ring with this. I hope your mama's got your back. First round, you thought you would've knocked me down. Fifth round, bleeding out the side of your mouth. Final round, pulling the sound of my name in the crowd. You hit a buzz. Oh, 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 oh. You hit a buzz. Oh, 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 oh. Just 'cause I took a break, you're making a huge mistake, thinking you can take the throne. Look at you trembling, step into the lion's den. Bet you wish you stayed at home. Begging for mercy underneath your breath when I ain't even sweating yet. My legend's written in the stone, yeah. You're crying age, in defeat is now your only friend. Even your mama's gotta know. First round, you thought you would've knocked me down. Fifth round, bleeding out the side of your mouth. Final round, pulling the sound of my name in the crowd. You hit a buzz. Oh, 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 oh. You hit a buzz. Oh, 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 oh,
Hello, hello. Welcome, everyone, to In Time. Jesus, we're not even going to be able to say we're in time anymore. We can't even. We're almost on time this time, but we're not in time. So we're putting the cart before the horse on this one. We'll be discussing that in a minute. But before we do that, Xandering, how are you?
I'm doing pretty good. A little muggy, a little humid. No AC, so I'm letting the fan blow all over me.
Oh my God! Are you in the Midwest now? Is that where'd you say you were?
Illinois. I'm in central Illinois, Bloomington.
Bloomington. What was the temperature out there today?
It's 82 right now.
All right. Yeah.
So it's not like I'm sitting here just sweltering like in a sauna, but when you're inside of the truck without much airflow, it gets pretty a little miserable sometimes.
Titan is correct. So I literally said, I still had the After Dark logo up, and I was like, oh, I'll switch it, and then I got distracted, of course, so I didn't switch it. I was going to switch it right during the thing. I didn't, and I was like, and I literally said, oh, they're not going to notice. Leave it to Titan, of course. Oh, dear Lord. All right, so
we get to be ahead of time today.
We do ahead of time. I like that. So it's not that we're out of time or no longer in time. We're ahead of time. So we had wanted to do. We've been trying to do something pretty significant on global warming. It's something that I think. I think a lot of people don't know how seriously to take it because some of the earliest reports said, well, we'd all be dead by the year 2000. That didn't happen. Some of us are wishing by 2022 that it had happened, but we're still chugging. And then there was the global cooling, then global warming, and we've talked about some of that and how that has sort of come to pass and why that's not there's sort of a misunderstanding of the claims scientists did make as opposed to the claims that were reported either by news organizations and so on and so forth. But we'd like to have a show really that sort of focuses on that. We've certainly heard some scientists come out and say, well, there's actually nothing we can do about it. We've already gone past the tipping point. Others say, well, the tipping point's about to. And so there's so much noise that it can be very hard to tell just how serious this is. And I think that's one of the reasons, aside from other pressing issues like COVID and Ukraine, that make it hard for us to sit and really think about this. So we wanted to try to gather what we could into some form of unified, okay, this is our best understanding of what we're looking at, how and why. And then we thought, wouldn't it be great if after doing that, we discussed what some of the sort of leading cutting edge solutions are to this? Well, we are not in time anymore, so we decided we're going to start with the solutions first. It's been one of those kinds of years. I think everybody would like to hear the solutions before the problems. So I apologize. We're going to get on Jason Torn, and he's going to discuss with us. We're going to do a good deep dive onto what we really understand about global warming, what we don't, how much of this is guesswork, how much of it isn't, and why is there this great misperception. But until then, we all do know that it is a problem, and we have been speaking with a man. His name is Greg. He is with the peer review show, which I managed to catch earlier. We'll be dropping a link to that in a minute, and I'll put a link to that in the description. So, he covers lots of scientific topics. We're going to bring him on. He'll tell you a little bit about his show and what he has been looking at for a potential solution to the global warming crisis. So without further ado, let's bring him on. And Greg, welcome to the show. How are you?
Hello, everyone. Good. Thanks for having me.
Oh, my pleasure. It's on top of everything else, somebody with a better microphone than me, which, by the way, isn't that hard to do, but still, it always gets showed up on my own show. So, Greg, thank you very much for...
That's why I don't...
yeah.
That's why I don't upgrade my headset. I mean, I have to make you sound better than me. I mean, it's not that hard. This is like a $2 headset, so it was really hard for me to find one of low enough quality.
Wow, you are feisty today. All right. Well, truth be told, I've been told that my microphone sounds best when it's muted. But at any rate, so Greg, thank you so much for joining us. So first of all, actually, could you just tell us a little bit about what the peer review is, so that our audience can know what it is that you're doing on YouTube, and then we'll get to your VC a bit.
Yeah, absolutely. Well, my name's Greg. I have a YouTube channel, kind of like broadly, it's science communication, kind of talking about the coolest things that happen in science that nobody talks about. So I talk about latest breakthroughs, papers that I find that are interesting. And then I also do a panel show called The Ministry of Science on Thursdays, where we kind of talk about like popular science issues and stuff like that on a more casual basis.
And in fact, one of the ways that we had that's how we had found you was through 𝐓𝐻𝐼𝐧, who I think you've had on, and he's been a regular guest of the show. So we're absolutely delighted to have you on, and I thoroughly enjoyed watching when I first bumped into you. I was like, a room full of people all very much smarter than me, but also making it interesting and approachable. So I hope people will go check that out. Now, and then at some point, I know Titan will fix the After Dark thing. So tell us a little bit about your background, how it applies to climate change, and what your work is.
Yeah, so I guess like kind of my research background is I started working in algae in 2010, and it was an algae lab. So we did research on trying to improve photosynthesis. So it was kind of like an algae biofuels in a larger scheme of things. But the project I was working on was trying to kill cancer with algae. So we killed non-Hodgkin's lymphoma stage 1 in mice with something that was made inside of algae chloroplasts. Mm-hmm. And then that was my undergrad. And then I went into industry, into a plant biotechnology company, and I worked with robots and doing microbial engineering with CRISPR and next generation sequencing of plants to make sure that we're making the right changes with CRISPR and all those genetic like tools that we have. And then I went back into academia for my PhD in microbiology. So currently I'm a PhD candidate in microbiology, and I'm working with nanotechnology, trying to use those type of approaches to better understand algae, but then also try to improve photosynthesis, to decrease stress levels, to better utilize it in the future, with biofuels, with different better materials, with food, all that kind of stuff.
Curing cancer, nanorobots, and trying to create a biofuel. Your mom must be so disappointed.
The nanoparticles, they're dumb. They're very dumb. They're very small and dumb. They're not as...
yeah. Well, still. All right. Well, so now.
Well, I feel like the dumbest person here now.
Yeah, well, don't worry. I'm not. I mean, compared to him, I think we're like exactly on the exact same footing. All right. So let's talk about now algae. So that's one of the ones, or plants in general. So you're the expert, so I'll let you sort of start where you want to. But what is it about? Now you hit on a lot that we would love to have you back. We'll talk about especially what it was that you were able to do with the algae to get a cure for. What was it? Lymphoma, you said? Non-Hodgkin's lymphoma in mice?
Non-Hodgkin's lymphoma, stage 1, yeah.
Stage 1 in mice. So I will ask, I'd love to find out, if you want to come back, A, or how you did that, and B, did it ever cross your mind to do it to humans? But that notwithstanding, oh, come on, that was funny. Okay. All right, fine. That notwithstanding, let's talk about the work that you're doing with plants and how that could apply to global warming. So global warming, we're looking at a number of very serious problems. We are looking at a rise in sea level that's going to cause flooding, especially of coastal cities, anything that's on an island, any countries on an island, of which there are a number, are going to obviously have a lot of serious problems. It's going to lead to great displacement of at least, I think the last figure I heard was at least 1 billion human beings that are going to need to be moved and find a new place to live, not to mention crops, both because of the receding land, but also because of changing weather patterns. Weather's going to get far more extreme. It's going to be harder to make food. We may lose species that are on the sort of lower end of the food chain that we rely on. So how serious is this problem in general, just sort of as an overview, do you think? And then we can dovetail into how you think that this may assist us with that.
I mean, it'd be easier to think of ways. I mean, the way that humans are negatively impacting the environment pretty much touches every aspect of human life. You can't really put it any other way. The destruction of the environment and is bad for human health, not just environmental health. And people need to realize that we need to conserve the environment, and we need to conserve the species that are here, and then we need to rehabilitate the populations and the species that have gone extinct. Those two things are the main key drivers for a healthy ecosystem, and we know this in ecology. This is well known. And basically, those healthy, productive environments are going to be able to better withstand these huge shifts that you're talking about. And what you're talking about are abiotic factors. So I used scientific terms just so that you can, people at home or whatever, they can look it up and kind of fact check me or learn more if they want. So abiotic factors are stuff that's like the environment, the weather's changing, the water, water levels and rain, that kind of stuff. Biotic biology is going to be like viruses, other organisms, predators, that kind of stuff. So what's happening is that we're basically taking a bunch of carbon that is in the ground that is in these things called carbon sinks. So carbon sinks are an ecological term for something that should stay where it is for a really long time, for hundreds of millions of years. And what's happening is that we're taking that out from the ground and we're putting it up into the air. And that's not supposed to happen that process does happen, right? Carbon does go from the ground to the air, but we're talking about on the scale of hundreds of millions of years. We're talking about like air and, mountains being exposed to air. And like, these are really small amounts of carbon over time. What we're doing is tons and tons of carbon and putting it up into the atmosphere. So basically how algae kind of relates to this is that algae allows us to use carbon that's in the air already, bring it down, and then we have the emissions process, which is, from the cars, right? So cars are gonna, or would, if we ran them on algae, and we could, basically those cars could actually bring down carbon and then put it back up into the air. It's a huge positive thing for the environment, because we're no longer mining for oil, and that's keeping us there. It's a renewable fuel, and it's also kind of like inevitable. The world isn't always going to have combustion engines just because of the physics of flight. So if you could never really have a 747 that's electric, because you get into these weird scenarios where it's like you need more power in order to put the weight up there. But then when you have more power, you need more batteries. And when you have more batteries, you have more weight. So now it's like a cyclical thing. It just doesn't work. But we're figuring out that we can use algae for that jet fuel, which is really cool. And that's something that the Department of Defense in the United States is funding heavily, because it's a national defense problem, right? If we can't fly the jets, then we don't have. That's a huge problem. We don't want to be, in the DoD's mind, they don't want to be. They don't want to be beholden to other nations. Full disclosure, I do have a fellowship with the National Defense right now, and I've had my research funded before. So for national defense. So, for example, this is one of the problems in Ukraine right now, which is we want to cut off all the energy exports from Ukraine. We are trying to punish the kind of behavior that they're engaging in. Problem is, a number of countries, Germany being one of the big examples, is highly dependent on it. And if you cut off the energy, you do a tremendous amount of damage to innocent countries. Germany in particular, there are ways to sort of help, but also especially developing countries. It ends up being, it's a security problem. It's a national security problem when we're dependent, of course, on if we're dependent on Saudi Arabia for oil. It means it has a significant impact on how we dealt with 9/11, for example, because of the significant investment. What was it? All but one of the hijackers were Saudi. And our dependence both on the oil and on their investment caused us to downplay that, whether that was right or wrong. And, it wasn't the Saudi government that did it per se, but nonetheless, it where the energy comes from certainly is beholden. Where the energy comes from certainly influences national security. And since we are not energy independent, we are not food independent, both of those things other countries can tamper with in one way or another. So that makes a lot of sense. So, and I'll point out. There's also another.
Yeah, please.
There's just one more thing that's actually an interesting application for this research. Like we were talking about the anti-cancer drugs that you can make within algae, but you can also make vaccines too. So you can actually, another kind of like next level, and this is kind of like the technology that really the DoD likes to fund, this kind of like next crazy kind of stuff that doesn't really, the NSF, National Science Foundation, the National Institutes of Health, Department of Energy, these are all federal funds, and they get combined around like $80 billion a year, but the Department of Defense does about $90 billion a year in just like this crazy next generation research stuff, the long shots they call it. So, but I proposed like if you had a terrorist, right, that had a bioweapon, and if we wanted to make a bunch of vaccines, basically the idea would be to have like algae bioreactors, or you could even do it with plants. You could go with, like, there's a field of plants or something. You could actually take some of those plants and actually make in the chloroplast, because they both have chloroplast, right? Algae and plants both have chloroplast, so you can use chloroplast biotechnology in both of them. And then you could use, plugging my lab, you could use nanotechnology in order to deliver kind of like the scaffolding, if you will, for the vaccine, and then basically create that within the plant. And so you could actually, the idea is, like, there's a bioterrorist that has something, we can actually create a vaccine rapidly, very quickly, that we could actually use. So that's kind of like, it's not all ironed out, but that's kind of like another weird offshoot in a science fiction kind of like thing, but it's actually reality, something that is actually tangible kind of thing.
Well, so, and we already do that, essentially, if I understand correctly, we're getting really to the cusp of my knowledge, but I'm going to take a stab at it. That's essentially what we do with things like E. coli, right? Which is we take E. coli, or we take something that can be used as a scaffolding that can replicate quickly. E. coli just replicates really quickly, and then we can manufacture whatever we want to within that scaffolding. What makes algae better than some of the traditional methods that we use? A lot of times we'll also do it in eggs for vaccines, so on. So what makes algae potentially better, or maybe even better right now? Well,
an interesting kind of like evolutionary fact about algae. I mean, basically, the chloroplast is a cyanobacteria, which has bacteria genetics. So kind of like what you're talking about, it's prokaryotic. So the genetics of the chloroplast are prokaryotic, but the algae itself is eukaryotic. So you can actually create things that are livable and survivable in the chloroplast that would actually be toxic to the algae itself. And this is kind of like, this is going into actually why that anti-cancer drug actually worked, was because we made something that was harmful to eukaryotic organisms inside the chloroplast, and it's kind of like gets trapped in there. So then it can't get out. And then you can kind of like using tools and cell biology tools, you basically disrupt all the cell membranes, grab what you want out of it, and then you can use it. So that's kind of like why algae is kind of a cool thing. It's using photosynthesis, it's using energy from the sun. But there's a lot of other applications for algae too. I mean, these are kind of like next generation applications. But for right now, like we even have like materials, so biodegradable materials that we can make within algae. We can make food, so you can have sustainable proteins that are being made. And biofuels, right? Like we were talking about before. So it's kind of like 4 unique ways that algae is really, really cool in what it can produce. The question is why not just in plants, right? So if you can make this in algae, then why not just make it in plants? Why algae specifically? And that's kind of to the productivity of algae itself. So algae is just basically one big chloroplast, while plants and stuff are kind of like, they have the skeleton of phloem and xylem, and they have these huge they have to make this skeleton basically, in order to put their solar panels on there, which are the chloroplasts. So, but algae are just one big chloroplast, and you can have millions and millions of algae, in a really small amount, 1 mil. So we're talking like a really small amount, a centimeter cubed of algae can have millions and millions and millions of cells in there. So think of how much space you would need in order to make millions and millions of plants. And algae can do this in a really, really small space. So it's really incredible. It's fun. Like, as someone that I basically am a molecular biologist and a geneticist, and I can, I change genes for a living. That's how I kind of explain it at parties. So, and it's way more fun to work with algae than plants, because plants, it's going to take me 6 to 9 months maybe to get a transgenic plant that's actually stable. With algae, I can do it in 3 weeks. I mean, maybe faster. So it's way more fun.
When the zombie apocalypse comes and it breaks out and everybody's running around trying to eat brains, we know that we should blame you. You made some mutagenic algae that you made the lab and got into the water supply and infected everybody. So you'll be the one we will blame.
Yeah, given the number of conspiracy theories that have come out with this kind of thing in the past, we're going to be a little careful with
that stuff
on a
is
slightly more serious note, though.
But that's a serious point. That is something that you have to write up whenever you have a mutant in the lab. I mean, this is very strictly controlled kind of stuff. So you have BSL levels, biosafety levels, where you have to properly contain, and a lot of these algae, like, to be honest with you, they don't have like a cell wall, so they can't really they're kind of wusses. They're not really gonna survive the nature. So
yeah, that's what they always say. And just watch any sci-fi movie where something like this happens. We all know that nothing can ever go wrong with making mutants in the lab.
Have you seen Jurassic Park, sir?
Nature finds a way.
Nature finds a way. Did you have another question you were going to ask, Xander? It sounded like there was something else you were going to ask.
I did, honest. I mean, not to downplay the safety protocols in place to stop mutant strains from escaping. I mean, that is actually, even though it's making fun of it with zombies, that is kind of important.
Yeah.
One of the things that kind of interests me, because I'm in the transportation industry and energy fuel is a really important part of that, and I think people are beginning to see just how important fuels are with the rising gas prices. My question is how realistic is it to transfer over to these biofuels from algae, and how fast do you think you could really do it? I mean, one of the reasons that we still use diesel primarily for just about everything is because of the amount of energy per liquid gallon and the fact that it's fluid at room temperatures. We've seen quite a big push for natural gas or propane, but there's some problems with that. Propane expands 14 times when it goes from a liquid, and it has to be pressurized enormously. The temperature has to be dropped significantly in order to keep it liquid. And the amount of energy in a gallon of liquid natural gas is only 80% of the gallon that is of the energy that is contained in a gallon of regular diesel. So there's some pretty significant issues with storage, being able to use it, refueling, and just the energy content. And of course you have all of the infrastructure issues. I mean, this is why like electric trucks, for example, are very, very difficult to get on the road because you don't have the kinds of range. That's why, the only kinds of natural gas trucks that I see are regional or local because, they can't go across the country. They don't carry enough energy. They have to refuel too many times. So how realistic is it that we're going to get these biofuels that will be sustainable, and how much energy do they really have in them? I mean, am I going to have to start carrying 500 gallons of fuel to go the same distance? And how do you get the infrastructure in place to do all of this? Because all of that costs money, and especially right now, we don't really have the money to be doing all of these things. So I'm just wondering how plausible all of this really is. I mean, is it really going to solve our energy issues, or is it more of a once we've gotten to the point that diesel or petroleum products are just simply too expensive, so people are paying $20-$30 a gallon for diesel before this becomes economically viable, otherwise cheaper to do the algae fuel than because biodiesel has been tried in the trucking industry and it's kind of universally loathed. It's a substandard. People don't like it. It causes lots of other issues as well. So I'm not sure if it was just rolled out too early, or if there's just some other things that we have to figure out when using it. So I'm just wondering how viable all this really is.
Yeah, these are all good questions. Basically, sorry, my dog's going crazy. These are all good questions, and I think that one of the unique things about algae is that it is what the term is like a fungible fuel. So a fungible fuel that actually an energy source that actually has the energy within its bonds. So you can actually use it, and you can transport it, and it stays the energy within itself, rather than, like, for example, a battery where you have to maintain a gradient and that kind of stuff. The nice thing about algae is that we could actually utilize the trillions of dollars of the infrastructures that we have already. So all of the gas tanks are going to work. All of the pipelines are going to work. All the gas stations are going to work. Even combustion cars right now, you just have to have a little converter on there in order to actually make it actually usable with. And one of my friends actually did that. He actually put a little converter on his car to make it run off of algae. So
what's the fuel?
It's uniquely.
What's the fuel? What's the fuel?
I mean, so we actually already use algae in plants in the oil and the gas that we take out. So right now, basically over hundreds of millions of years, the weight of the Earth has made this lysate, or crude lysate, whatever they want to call it, crude oil, that basically all the parts of the plant have been atomized basically and are all in one little slurry. And what we do is, what the gas companies do is that they're extracting everything, and then they're actually separating out based off of the length of the carbon, the lipids or the fats. So it'd be the same fuel. It would be the same fuel that you're using now, that you're putting in your car. Nothing would actually change. So that's the kind of the huge advantage of it. And I mean, my 92 Ford Ranger can actually go renewable and sustainable off of algae biofuels. We couldn't do that with electric vehicles. I have to buy an all new car, right? So it has huge advantages of stuff like that. Like right now, we actually have 10% of all of our gasoline is made of corn ethanol. So that's uniquely bad, actually, because corn is very inefficient. Algae is about 40 times more productive than corn, and corn's made a lot of it is made for that 10% ethanol requirement. That was a Clinton administration bill. So, so we could, changing that, going into something more sustainable like algae, like in 2010, for just to give you like how much space would it need? How much space, what are we looking at, kind of thing. In 2010, basically we would need algae pools the size of Texas in order for this to be feasible. And then, but now with current technology, we're looking at the size of Montana. So it seems like really a lot, but then if you get rid of some of those corn ethanol plants, you get rid of the, and you put algae ponds in there, you're looking at something that's way more productive. And just to say like, Montana sounds like a lot of area, but you couldn't do this with plants. Like you couldn't do this with land plants at all. So the fact that there actually is like a feasible, tangible amount is actually kind of crazy.
You can take Texas.
So when are we going to?
Yeah, you can just take Texas. I don't mind.
How far away would this be? I mean, it sounds all really great, and I would love to do it. And having algae pools, hey, more oxygen on the planet is always great. Plus, it pulls carbon dioxide out of so having algae pools would be awesome. It would really help. How long would this take?
Well, yeah, you're right. Over 50%, 50 to 80% of the world's oxygen comes from algae already, which is kind of cool. But the Department of Energy has the BETO, which is the Bioenergy Technology Office, that's just putting out their recent assessment. And we're talking, it's happening. It's happening right now. People don't know about algae or algae biofuels, but it is something that's being actively researched, and that is a future. It's in the pipeline. So, but the problem is, I guess, I don't know if it's a problem as much as like there is more of a push at the consumer level, I would say, for electric vehicles. So this is kind of like a little push and pull kind of thing. Electric vehicles are kind of, have their own problems. And
like lithium.
Yeah, and the battery waste and that kind of stuff. I mean, personally, I guess if we wanted to, 10 years ago, 15 years ago, we could have probably done, all algae biofuels, and it would have been we could have switched entirely, as a country. But it seems like electric vehicles kind of like won that battle. And, I don't know where the trillions of dollars is going to come from in order to have the battery swap stations and all that kind of stuff for electric vehicles. I like the idea of using algae biofuels because it would, at the consumer level, it doesn't change anything. I think that's a huge advantage. I think that's kind of the solutions that we need to kind of think about when we're actually going to try to tackle something as big as the humans' negative impact on the environment, which is mass. So
So you pointed out that these biofuels could be used in pretty much any more modernish type of vehicle with just an adapter, which means that all of the current infrastructure is still there and viable and usable, which would save trillions of dollars. Unlike the issues with battery. The problem with one of the biggest problems with electric cars is the battery itself. I mean, we don't have good enough batteries, and there isn't enough lithium to make all of our transportation needs electric vehicles. I mean, we just don't have enough lithium to make that many batteries. So, I mean, it's not going to win in the long run, just because currently, unless there's an advancement in energy storage, battery storage, I just don't see how the electric vehicle is going to ever be a viable replacement for everything that we're doing now. But one of my questions is okay, so let's say we make this change, we get everything set up, so we're going to do the algae. What are the byproducts of burning an algae fuel?
Well, let me dovetail on that. It sounds like the byproducts will be, in fact, be identical because it's actually it's the same gasoline essentially. It's been manufactured now. So we're not pulling it out of the ground. So we're not taking the sinks out, but we'd still be putting carbon into the air, would we not? Because it's the same gasoline. So
but it would be the carbon that. But they would be pulling carbon out of the air, so we wouldn't be adding any more carbon to the air because that's where they're going to get the carbons. Algae.
Exactly. Yeah. So the carbon added or the carbon footprint of algae biofuels would basically be the carbon footprint of the process to go from an algae pool to like put it into my car kind of thing. So, and we know this process pretty well now, and we know that it's actually. So algae lives in water. One of the advantages is waste. It can actually live on wastewater. It can live on a gray water. It doesn't have to be like pure water. So that's another big advantage. It's not just eating fresh water, because fresh water is a finite resource on the world. So I'm sorry, I lost my train of thought. What was the question one more time?
My question.
The carbon footprint.
Yes. It's removing the water from the algae. So that's actually the biggest thing. We know that the lipids, and we know that lipids obviously are going to separate from water, and so it's not good to have water in the extraction process. So basically, figuring out how to the crude way is just to evaporate off the water, right? But like boiling, the huge algae ponds is very inefficient. So there's all the technology and business like push right now in algae biofuels is actually solving this problem. The engineering money is going into solving and trying to figure out how they're going to remove the water without it costing a ton of money and carbon.
So what is the biggest problem going forward? I mean, we're obviously not going to do this tomorrow. One of the biggest problems with, for example, batteries is what you had said earlier. It's the weight versus the energy that you can actually get out of it. It's only recently gotten efficient enough. And I remember when they were trying to deal with this with cars and solve it, where you could actually have a car that could propel itself because the weight of the battery was so heavy, and we just had to improve the technology and improve it. But the bottleneck was the storage versus the weight. It had the ratio had to come down below a certain point before we could even start to do it. And it still isn't low enough to use ubiquitously. It also doesn't solve the energy problem. It just stores it, and you can, maybe recapture it, when the car goes downhill, yada, yada, yada. But, okay, solar, same, you also have a problem right now. We're not getting enough without the batteries. You still have the problem with solar because the sun goes down. So how are we gonna, if we don't have the ideal battery solution right now, and since solar doesn't generate as much as we'd like to out of it, you have those two bottlenecks in solar, you have bottlenecks in wind. What's the bottleneck here that's been sort of keeping this from just hitting the ground and starting with it tomorrow?
It's an interesting question, because I think that, like, part of it is I don't think that people know about it.
Mm-hmm.
Like, I don't know that people really know that, like, they're being sold like this false narrative where they have to buy a new electric vehicle in order to be environmental. But, like, man, you can buy a Tesla and go to Missouri and drive that thing till the cows come home, and you're not going to impact the carbon footprint. It's actually going to be really bad, because Missouri gets their electricity from coal still. So a lot of the country still uses coal as their primary way of generating electricity, and a lot of people don't realize that.
Well, the other problem with that too.
Mm-hmm.
Sorry, I hate to cut you off.
No,
the other problem with it too is it's like, look, I own a 1969 Jeep J4000 Gladiator pickup truck. I mean, it's a 1969. So obviously it's not particularly efficient, at least not compared to standard cars today. Yet to scrap that truck and go buy a new Tesla, the carbon footprint to have created that Tesla is still larger than me just continuing to drive my pickup truck. So I've got it fairly tuned up. It runs pretty well. It's not that bad. And so the continuing carbon footprint of just driving that truck and not purchasing a brand new electric vehicle, I'm already lowering the carbon footprint by just not buying a new vehicle at all. I mean, they've shown time and time again that keeping the vehicle you have and driving it, even if it's not nearly as efficient, is still a lower carbon footprint than producing an entirely new car to purchase. So, I don't see how that's whereas your idea with the biofuel is people are still using all of their own cars. They don't have to go purchase a new vehicle. So I can still drive my 1969 Jeep pickup truck around on this stuff, and at least we're not pulling carbon out of the ground to put it into the air. We're pulling it out of the air and then putting it back into the air. I mean, I'm not sure. It kind of makes me wonder long term, because there's got to be other harmful things burning that fuel, because there's like in gasoline, you get quite a lot of carbon monoxide, which is not good for you. Diesel, not so much. I mean, do you just see us moving away from gasoline and going straight to just diesel? I mean, diesel actually is less pollutant than gasoline is, but
yeah, that's what technically it is. It'd be biodiesel that the algae would be.
This brings up another question. You had mentioned coal. So we nuclear has often been referenced as the only way we're going to really get out of this, because, as much as everybody hates nuclear, every other solution we have at some point usually relies on electricity generated from coal plants, which is just absolutely terrible. Will this biofuel be able to, at some point, if not immediately, do you project that it will at some point be able to replace coal?
It's kind of two different reasons to exist. It's kind of like all of the above strategy that's needed in order to really tackle something as big as all the ways that humans are impacting the environment negatively, which is vast, right? So nuclear is something that is good for nature. I'm not anti-nuclear. I'm not pro-nuclear. I'm ambivalent. It's a technology that's cool, and I don't have anything against it. I think that it has its place, and especially really dense nations that don't have space for solar arrays or wind farms and that kind of stuff. So if you think about some like a place like Japan, for example, they don't have the, the space to put on, like a huge wind farm. They could put all the solar panels that they want on the top of their buildings and, put, the turbines up there, but it's not going to be enough. Right. So, something like that, I can understand how nuclear can be like a really, a huge advantage for a really dense nation. For the United States, it doesn't really make that much sense because we can go more of renewable source. So, whether, the biggest problem with nuclear is basically it's not a renewable fuel. Bar none. There's these, there's a lot of different type of nuclear reactors, and there's always going to be like someone that's like, oh, there's a breeder reactor though. It's like it actually, and that's cool. That's fine. That
and it's
it does
perfectly
exist.
safe. It's absolutely perfectly safe, I'm sure. But anyways, please continue.
I mean, I've read these, the international nuclear energy, symposiums and that kind of stuff, and they're talking about this stuff, and even they say that this isn't the breeder reactors, just they are not efficient as they thought they were, basically. And there's like 50 years of technology going into them, so you're never going to get this more energy. The uranium is going to deplete over time, and you're going to need to put more uranium in there, basically. And that the benefit of a renewable fuel is that it can go the long run. Like the wind isn't going to run out, kind of thing. The sun isn't going to run out. Well, I mean, in billions of years it will, but this is kind of like not. We're kind of solving now.
Yeah, we can wait on that one. I don't think that's a priority.
Yeah, exactly.
Yeah.
So it's like
that's a tomorrow problem.
So that is one of the few ones where it's okay to kick the can down the road. I'm not for kicking the can down the road. That one you could go ahead.
Well, one of the challenges that we face today is that we don't have a renewable. I mean, it kind of annoys me when they say renewable energy. It's like, oh, the wind won't run out. You're right, but the energy and the materials used to make carbon blades will run out. I mean, probably not nearly as fast as maybe oil will, because a lot of those parts are pretty common. Solar arrays, solar panels have come a long way in their efficiency of converting, electrons into or photons into energy. But there's the battery, the storage technology is a challenge, and so none of the energies that we have right now I would consider to be actually renewable. But we need something to tide us over, because we see what happens when energy becomes less abundant. I mean, you can look around at most of the world right now, and the energy prices are spiking, and it's causing a lot of hardship. I mean, this world runs off of energy. So it's like we need something to tide us over, so we can find something that I mean, it's going to be difficult to find something that's like because you can't really produce more energy from what you get. I mean, you have to have some sort of external source, and which I think is going to eventually be some sort of solar, because the sun is there all of the time. I don't know if you have like an orbital energy collector for the sun. I mean, there's lots of ideas for that, but we need something to tide us over till we can get the kinds of technologies together to make this more efficient. And we can't, unless you really want to cause a huge amount of hardship, around the world, you can't really just cut off the energy production we have now. Is this algae thing, do you think that's going to be a good stopgap to get us going? I mean, you're still burning a fuel, so you're still putting pollutants into the atmosphere. Although I like the idea of plants and algae actually help clean the air as well. So, do you think this is going to be a good stopgap measure, or do you think this is something that it will be used long term, or is it not going to be a stopgap and we just have to wait for another 20, 30 years before this is even viable?
I don't know if it's going to be. Yeah, I mean, a lot of the power plants right now in the United States are run off of compressed natural gas. So I don't know if this is necessarily for that. It could be, the methane that exists in that. I guess you could get it somehow from the carbon from algae. I don't know exactly the process. It's not my research area. So, but yeah, that's kind of like interesting. I never thought about using algae as like, for a power plant so much as like trying to, use the fact that it is a fungible fuel, that it can act and be that thing to help all of our cars. Go ahead.
Well, no, I mean, natural gas is produced in much the same way, and coal is produced in much the same way as oil. It's a different, so it seems to me if algae can produce one, it should be able to at somewhere along the line be able to produce the others, I would think. But this is what.
Yeah, I mean, I'd much rather use like algae pools than fracking or coal mountaintop removal. So yeah, I mean, like just there, one of the most famous papers that I've seen on algae in a while was actually just using using algae to actually run an Internet of Things like device for like 6 months or a year or something. So they had like a little algae cell, and they used the oxygen that's produced in photosynthesis from the algae and to actually power something, which I thought was really interesting. So, and then there's also been research done on algae in solar panels. So that's like another interesting application that's kind of like more on the engineering side. I'm kind of like more on the biology engineering side, improving photosynthesis, improving the ways that we can actually change these things, change the algae. That's kind of like where my research is, like genetically mutating them to do to make the longer chains and that kind of stuff. But algae is used for a wide variety of things. But I'd be hesitant just to be like it's this the solution to all of our problems kind of thing.
But you see, that's why you need a professional like me. So you see, here's the thing. Like, you see, so like how a psychologist can't diagnose people. I can diagnose people because I don't have, I'm not a part of the American Psychological Board ethics. I don't have to worry about that ethics because I'm not a psychologist. So I can diagnose people who aren't patients of mine because I don't have to.
Convenient.
Yeah, it's perfect, right? So, you can't get a psychologist to diagnose people who aren't patients, but I can. And because I'm not a scientist, I can sit here and say that this is absolutely going to happen. It's brilliant. I think it's great, and I think it's going to solve everything. And you can trust me because I do a show on YouTube. So
I guess you're right.
It's a panacea of solutions.
Yeah.
The compressed natural gas apparently was the original fuel for internal combustion engines. So I guess it is a way of going forward. Well, I mean, it is really cool. I mean, we are the algae research is going, and we're hitting our milestones, and the new Beta report says that we're hitting our productivity numbers and stuff. So it is something that's really inspiring, and it's one of the reasons why I feel like I'm optimistic about the world and how humans are interacting with it, and I say that specifically not just for climate change too. I mean, climate change and CO2 emissions and stuff is just one negative way that we are impacting the environment negatively. There's a mass extinction that's going on right now, and that's going to be kind of like its own cascading, problems as well. And on top of the carbon dioxide making a feedback mechanism to cause their own extinctions, like our own uses and land uses and agriculture, and that's all being the environment's being impacted that way too.
Well, I personally, so I only got one or two more questions. Then Xander, we'll see if you have any others left that you wanted to ask. You had me at size of Texas. I don't think you have to take out Montana. I'm perfectly fine. Texas wanted to secede anyway. We'll just, Texas is just going to be. But so What specifically has been the barrier that was overcome to get? Is it efficiency? Is it storage? How much you can store in a particular spot? Is it how much energy you get out of it? What has reduced the amount of space required to store this, and how much further reduction? I mean, obviously, there's a law of declining returns. At some point, it's not going to get much smaller. How much further reduction are people looking at for this realistically in the next, say, 5 to 10 years?
So, yeah, I mean, it's interesting. Like green algae has actually been kind of the way that we know so much about molecular biology, molecular cell biology, just so much about microbes, and from that knowledge was basically our in-depth knowledge about 𝗬𝗲𝗄𝐴, which is a single species. Basically, it's from soil from Massachusetts from the 1950s. Like literally, there was a soil sample, and that's where so much attention and research has gone, and it's allowed us to kind of like develop these molecular tools, kind of understand the cell better, understand the chloroplast better. And then now I think the big leap forward is basically the genetics and molecular biology techniques that we've developed with, CRISPR, stuff like that. We're able to actually create strains now in a wider variety, not just 𝗬𝗲𝗄𝐴, because remember, there's millions of strains of algae. I mean, it's crazy the amount that's out there that we don't know. 99% of microbiology is unresearched and not genetically changeable. We have no idea what's out there actually. So there are species of algae out there that are full of lipids and have these unique ways of making lipids that we could use, and basically using new tools allows us to kind of like survey what's going on in the environment, and then use some of those tools and make our own algae strains better. So it's breaking out of 𝗬𝗲𝗄𝐴. It's doing the molecular biology. It's doing the genetics, using synthetic biology to survey all of microbiology and millions of new strains. Getting past like Koch's postulates, for example. We're not going to be able to take every single. Maybe the future is of algae ponds is some type of heterotrophic culture of algae and bacteria, or who knows. It's a crazy world, and we're just now beginning to figure out what's actually out there in the world of microbiology. It's an entirely new frontier, like some real cowboy stuff going on right now. So it's really fun.
It's interesting to hear about.
Yeah, please, Zerner, and any other questions, please.
Well, yeah, it's really interesting to hear about some of the stuff, research and discoveries that are going on in the world of microorganisms. Like they recently found, microorganisms that live in nuclear reactors. So, I mean, literally, Malcolm was quite right when he said life finds a way. So, the only reason we care about the environment is because we have to live in it. I mean, if all the humans are gone, nature will find a way to rebuild itself and rebalance itself, and even a lot of things might go extinct, but the world of microbiology, which is where all life, came from to begin with, is so huge and so diverse and so adaptable, that I'm pretty sure that it would be very hard pressed for humans to make life on Earth impossible. So, we only care about the environment in relation to ourselves and being able to live in it, because we need some pretty narrow parameters in order for us to survive. Mm-hmm. I'm still kind of wondering, how far off are, actual applications where we're seeing it applied in the real world, people using algae-based biofuels, how long off estimated? I don't expect you to know exactly. I'm not going to hold you to a prediction, but
I will. I'm writing this down, and we're going to have you back, and you're going to have to answer for this, but please.
There's 747s that are now there was like a pilot flight with a 50-50 blend of algae biofuels that did a test flight. It's one of those things where the DOE is putting the money into it, and it's going to happen kind of like as the corn ethanol kind of like dies down. I think that we're going to see that the DOE is pushing for, based off of the reports that they're putting out, looking at consumer electronic vehicles being basically like all electronic by like 2050. So by then I could see some type of algae ponds used in order for renewably make our to make our combustion engine the jet fuel. Basically, I think that's where the real push is going to be for. You're not going to. I mean, theoretically, you could make an algae pond right now. There's nothing stopping you. The thing that I wish people understood is that like the technology exists right now. Like in order for us to be, living sustainably off the environment, that we're not negatively impacting the environment as humans, we're not exploiting the environment as humans. All that technology exists right now. The question is, why aren't we using it? Why aren't we flipping the switch? Why haven't we prioritized the environment? Why don't we see environmental health tied to human health? Especially with something like SARS-CoV-2, something like that, where it's like you do, like we were talking in the pre-show, about there are viruses that are thawing in the permafrost. That's a real thing. We talk about it in sci-fi movies, but it is something that's actually happening. So there's a really interesting paper that came out about 25 years ago now, and they're called ecosystem services. Ecosystem services are the way that the ecosystem does things for us in order to live like as humans. So what we're talking about is like making our oxygen, or bringing down nitrogen to make nitrates, through nitrophilic bacteria, so that you can actually put nitrates into the soil. Pollinating our plants so that we can actually eat food, all these things. And it was a huge hubbub that happened about, because this paper came out and it said it was like $3 or $4 trillion a year in ecosystem services that the environment does for us every year. And there was a huge backlash in ecology, and it was like, everyone was like, no, you don't understand. Like every single thing that we do or touch or that's made is tied to the environment in some way. If you can look around you right now, every single thing that you can see right now as a human, we've had to take that from the environment. We manipulated those atoms to make something else. So it's kind of like, why haven't we decided that the environment is important enough? That's the better question. I feel like I don't know that, that's a good question for politicians. I feel like, why haven't they prioritized these things? Because there's huge benefits to these. The biggest thing I think that the problem is like, there's some cost, to it. It's too expensive. I think that's a bad way of thinking about it, because what we're talking about is a new paradigm shift and new materials that are possible. Like, for example, there's
like the paradigm shift into plastics was a good example of that happening.
Yeah. So like we can like, for example, we can have concrete now that actually can grow and as like kind of like a tree. Have you seen those pictures of like the in rainforests where they actually take tree roots and they actually put them as bridges, and you can, as time goes on, they actually get stronger and stronger because the trees get stronger and they get larger, so the roots get bigger, so the bridge gets better and it's more sturdy. We can actually do that now with concrete. We can actually create photosynthetic concrete that actually gets stronger over time. It's stuff like this. I mean, it's the only reason why it's so expensive is, partly because of a cost of scale issue, right? If we're talking economics, like, there's the first person to do it that's going to pay the highest price, and then it's going to get cheaper, after that. So as, the United States, I think that's our future in this century, at least, is, leading the charge in making these green jobs, making these green, new products, and then selling it to, the entire world. And that's going to help everyone's economy.
I know you're not an economist,
Yeah. You and I are going to the same place on this one, I think. But please, Xandring.
It's like I know you're not an economist. That's not your field of study. But I have to ask because I don't have a better person to ask. So you're in charge of budgeting in the United States. What amount of money do you think needs to be thrown at this to make it viable? I mean, concrete that replenishes and grows sounds like a really great thing for our roads, since concrete gets worn down by traffic. So having a concrete road that actually gets stronger over time instead of breaking down over time would be immensely useful, because making concrete roadways is actually quite expensive, which is why we have lots of asphalt roads, because that's cheaper. Doesn't last as long, but it's still overall cheaper. So how much money do you think we need to throw at this to get these kinds of biofuels, to be able to get this, to get this kind of algae-ish technology up and running and into the world being used? How much do you think that's going to cost? That is, I mean, I know people are like, well, how much is the future of humanity worth to you? It's like, that's a great platitude. But when real people are beginning to starve, or real people are falling into poverty and suffering, that causes a hell of a lot of disinterest and even animosity against some of these programs. I mean, look at what happened with the ethanol. I think, we're going to be pulling out of ethanol here very quickly, because we're starting to see some global grain shortages. And, there's a lot of poorer countries that kind of got pissed off at the U.S. over shifting so much, corn production into ethanol versus actual, food. So how much money are we talking about to try and get this going? Do you estimate?
Yeah, I mean, the corn ethanol thing is actually a really weird thing, because it actually tied the price of fuel to the price of food for the first time in a really weird way. If you look at the price of fuel versus a bushel of corn, they're very correlated, right? So it is kind of weird. I don't have like a specific number. Obviously that's going to be tough. We spend about $90 billion in research in the DoD on like a lot of things, and it's not necessarily all climate change or human environmental impact related. The DOE is one of the smaller budgets in federal in the federal funds. The NSF does have funding that does do some of this, but they're like around like 25 billion. DOE's like 15 billion maybe. So it's one of those things where I don't know, especially when you have like oil companies and stuff that are actually subsidized with tax cuts, like that's what I don't understand. Like it's kind of like a false dichotomy, right? Where you're presenting this thing where it's like, why isn't algae so much cheaper? And I'm not saying that you're doing this. By the way, I'm just saying in general, like how, like, when is it going to be when is it going to cost cheaper than the oil companies doing it? And it's like, well, dude, the oil companies don't actually produce anything. The oil companies don't produce a product. They extract the product from the earth. The earth has made the product, and they just refine it, and then they sell it to us. And yet it's the most profitable venture that's ever existed in the human existence. And yet we still subsidize it through tax breaks. I don't understand. So, if we, shifted those tax cuts and tax breaks, if we did something like California does the carbon credits system, which has created hundreds of millions of dollars in profit for Tesla, rightly or wrongly. I don't that's not for me to decide. So I think that like California doing that does play a big role, because they're the 5th largest economy in the world. I think it has to be like kind of like a structural thing rather than a specific dollar amount.
Well, and if I understand correctly, what you're suggesting is it's not even all that expensive or so much more than what we have currently. The problem is the motivation to switch. And I think one of the issues is there's no lobby for this. There's a huge lobby for gas and oil, and those are extremely powerful, obviously. And that's also why we have the corn syrup. So we started subsidizing, and it was Clinton, when you had mentioned, actually, I think it may be even before Clinton. I think Clinton was the biggie, though. Started subsidizing farm.
I have to interrupt you just really quick. Why in the hell is it that there are so many policies that if you ignored the actual policy and just went kind of with what the intent was, it sounds so great. But when you look at nobody bothered to look at the unintended consequences of all of these policies. And now we're having these huge issues because of these unintended consequences. Turns out that they were really bad ideas.
I don't get
so many of them go back to
the housing. Yeah.
It was like they finally, you read the bill and the press releases, and they're like, we're finally doing something that's sustainable, guys. We're actually doing it, and now all these people, these farmers are growing corn because they know that there is a demand for it. So we have to kind of like buy them out, basically.
So
exactly.
So what Clinton did was, he was going to subsidize. He was going to pay for the corn even if it rots. So everyone started making corn because there was always going to be a product for that. So we started overproducing corn because you knew, not a product, a buyer. Clinton was always going to buy it. The government would always buy your corn so that you had a product you could sell. So we started switching to corn, and we ended up having much more corn than we needed. So they started trying to find ways to get more corn into products. That's why we started putting corn syrup and everything. And that's one of the huge reasons we have an obesity problem. It gets right back to, it's Clinton. And I know why Zandrick jumped to that, because one of my pet peeves too, which was Clinton trying to do a marvelous thing, get every American into a home. And 30 years after that, a little less than that, 20 years after that, you get the mortgage crisis. Because he puts his hand on the scale and has no idea what he's doing. But on the flip side, I think it's that they don't care. I think it's the pushing the can down the road. I think the problem is there are no lobbies for this, and there's a huge number of lobbies against it. So let's assume that the cost is roughly the same, especially once you've transferred over. The problem is there's no way you can. How are you going to spend time with a congressman and get them to get on board with this if their district is a coal district? And that was one of the things that got Trump elected, right? Coal companies aren't coming back. Coal is not coming back. But Trump comes out and says, yeah, it is, and I'm going to bring it back. And he didn't because he can't. Whether he knew that or not is completely irrelevant. I don't think he actually knew it. I don't think he cared. That notwithstanding, that's how he got elected, was by saying that, because that was actually a huge, now it wasn't a lobby in the sense that it didn't lobby Congress, but it was a lobby for Trump, and that was a huge part of why he got elected, was by saying we're going to bring the coal jobs back. Doesn't matter that they're killing us. It doesn't matter that. So I think the big problem is how do we change the perception? I think sort of what you had said earlier, because the problem is the coal industry, the people with the money get to set the narrative, and their narrative is you're putting people out of work and you're causing a huge amount of people to suffer, which any change in technology did. That's why they didn't like ATMs. When ATMs first came out, there was this huge cry, you got to shut those things down. You can't have those, because think of how many people you're going to unemploy. It doesn't actually work that way. Those people are still working, but. At any rate, let me quickly, $2 super chat, Sinister Porpoise. Welcome to the In Time Solipsist Society. Yes, I have no idea who Porpoise is welcoming, since ostensibly, I think I'm the solipsist, but I think she's going to disagree with me. If she's the solipsist, she doesn't need to welcome everybody. They already know they're here. At any rate, thank you so much for your super chat, Porpoise. Thank you so much for your support. What were you going to say, Greg? And then I think we're going to wrap this up.
Yeah, I mean, I think inevitably, we talk about how humans are negatively impacted the environment, and we look at it globally, right? We look at this problem, and we do see impacts globally. It's not just a specific nation that's having these problems, and we don't see it's tied to the human experience, that we're not interacting with the environment correctly. We're seeing ourselves as on top of it and not living with the environment. And I think this is why this issue, it can be so daunting and so depressing to think about, because it's like, how do you change the world? You can't, right? You're not going to have like a world solution, which is why, a lot of Republicans will talk about like, oh, you guys just want a new world order or whatever. And it's like, well, no, we're just, people just want a global fix to this problem. And I think that people should focus on things that they can change. That's the only way you can maintain productivity. That's the only way that you can actually maintain your sanity, is actually working on things that you can change and seeing that progress being made. So how can people do that? We know that there's a huge benefit to conserving species and rehabilitating them. And we know, for example, like connecting natural places and natural, nature together creates that. So like, for example, like you have a direct way of actually impacting the environment and bettering the environment and making it more productive just by like going to like a zoning commission meeting or something like that, your local city hall, and saying, hey, this space is really important. We can't divide this with a parking lot. There's commissions, there's boards at your city hall that are unelected that you can go in and you can actually get involved with at, 5 to 10 hours a month, and you can actually make a huge impact at your local level, and you can have cascading impacts, beneficial impacts on this problem. So it's not just doom and gloom. You don't just have to be a scientist in order to contribute to this problem. We're not trying to fix it overnight. We're trying to make progress over time, and you can do that at the local level. And if everyone did that at their local level, then we would have huge progress.
On that inspiring note, I would
please.
I have to point out a slight side topic, mentioning about when I made mention about algae producing more oxygen for the atmosphere, where people are like, hey, let's get the oxygen level back up to that 30% so we can have giant insects again. And I had to point out that 10-foot tall spiders would certainly solve any overpopulation issues, and also benefit to me. It would garner a hell of a lot of support for gun ownership.
That's true.
That's honestly, I'm like a hobbyist entomologist, and that's when people say, if I had a time machine, where would I go? It would be back to that giant insect time. I think that would be such an incredible time to be on the earth, and that would be so cool.
I think Andrew's got a really good point. I think there's going to be a lot of fans of the Second Amendment if we get those bugs back. Oh, dear Lord. All right. Well, on that note, I will say, I was curious to hear what you were going to say. You and I had spoken a little bit, so I had some general direction, but I'm cautiously optimistic. It sounds like really the biggest influence is going to be the politics of it, which is always. I mean, again, and farms are actually a huge lobby. It sounds like they wouldn't be, because they're usually barely hanging on, but they're a huge lobby. Oil is obviously a huge lobby. Exxon Valdez, what was it? Exxon Valdez, that was Exxon Mobil, was the, what is it there? If their income was GDP, they'd be the 11th largest country in the world, just as a company. So, there's issues. But I
do have to say, though, I mean, they're not just taking this lying down, right? So the gas, the oil lobby and stuff there. I mean, for example, they've donated, Exxon's donated, I think it's like $400 million to J. Craig Venter in San Diego, doing awesome algae research with synthetic genomics. J. Craig Venter Research Institute was founded with that stuff. So, I mean, they are putting money into legitimate algae research. And I know people say like, oh, they're just doing this because, it's for show and whatever. But it's like, those are legitimate scientists, so that is legitimate research that's being done. And I think that they see kind of it.
Well, they know there's the writing on the wall. They're not stupid, and they
Yeah, exactly.
we've seen the,
see
the
it.
leaks. We've seen the leaks, and they've said we do have a legit problem, which is, and now they haven't looked at it from the way we might want them to, which is what they've said is we have a limited product. There is a limitation. At some point, we're done. So we have to move on. All the global concern and environmental concerns notwithstanding. So they've actually genuinely been looking at this. And I think it was a real. I appreciate you bringing that up because I think, and it may be complete self-interest. They want to sell us something else, but hey, if it solves the problem, it solves the problem.
I mean, of course it's self-interest. I mean, just from the person who really gets on and gets a good, efficient way to produce, algae fuel, that they can produce as much of as they want. I mean, there's no limit to how much was made back in the past. How many things died and decomposed under the. Yeah, of course. I mean, the person who's going to be on the cusp of that, who really gets a good, efficient way of producing this and getting it to market, they're going to be the next, Carnegies. They're going to be the next, billionaires that are. So yeah, I mean, there's a hell of a profit, and most of the oil companies out there are spending quite a lot of money in research for alternatives to, ground-based oil.
Mm-hmm.
All right. Well, so on that note, it's nice to. Yes, I'm sorry. What were we going to say?
I just would like to see this. I just would really like to see this faster. I mean, it's not like I don't care about the environment. It's just how do you balance all of the needs of people? Because if we just wanted to do all of the proposals that people who are, the environmentalists want, you're going to kill off half the planet of population right now. I mean, you just have to do that. So, I'm very interested in finding actual solutions that we can do. So, and this sounds very promising, especially considering all of the infrastructure is in place to be able to use these fuels, and people would only need to upgrade their vehicle to whatever it is they need to run. I know many of the vehicles are tri-fuels that are produced today. I mean, they can run off of natural gas if you wanted to. This is a change in the program, and obviously changing the fuel system, delivery system. But they can just change it in the programming in the computer. So I mean, all of that's already there. It sounds like a really good, plausible way to get off of petroleum products out of the ground. And it seems like something that we could do reasonably quickly. So I'm very excited when I come across things like that. So I'm very happy that you came on to share, because I knew nothing about any of this.
Thanks, I appreciate that. Talking about timelines, I mean, we're fastly approaching where that 10%. If the DOE is right and we're all electric by 2050, then basically 40% of the corn that's growing right now is for that 10% ethanol requirement. So that's a lot of cornfields that are going to be empty, and we have a way to utilize that space, and we have to make something that's sustainable and productive, 40 times more productive than corn. Algae pools are they're big. You should look up pictures of it. They're really big and they're long, but they're actually they're shallow. They're about a foot deep, just because that's how light penetration works. But it's really cool. Just the different bioreactors. There's a lot of different ways that people can get involved with this idea, and people have to make the raceways. They have to make the bioreactors. They have to purify the oils from the algae. So there's a lot of jobs that are associated with it, and it's not like you can just ship this algae lysate or whatever across the world. It's going to be jobs in the United States that are going to be what people are going to be using in order to get this labor done. So I think it's a lot of space. 40% of corn right now is for that ethanol requirement. Only 10% of the corn that we eat is only 10% of the corn that we grow is what we eat. It's mind blowing. It's mind blowing.
Yeah. Well,
a huge amount of corn is grown as silage corn for livestock. So that's a huge, like in the Pacific Northwest, almost all of the corn, nearly all of the corn grown in the Pacific Northwest is specifically harvested as silage for the dairy cows. So It's
Yeah,
like
it's
we don't
crazy.
even eat that stuff. So yeah, it's the corn, the uses that we've done for corn and the push into getting so many people into corn I don't think has been a very particularly, productive. I think it's been counterproductive, but money and, all of the subsidies that the government threw that way too, just so they could say they were doing something. Yay, ethanol. I mean, turns out it wasn't such a great idea.
Yeah, it kind of it set us on a weird path, and the whole world too. Like I was saying, the whole food fuel coordinated thing is very odd. I just wish I think kind of like what you were talking about, like the intention's there, but if like the intention's there, then like, okay, so let's reshift. Like a lot has changed since, this has passed, so there's been a lot of technological and development since then. So it's time to rehash it, but also, you can call your congressman or your senator and talk about this one, but again, like think locally, for real, think about ways that you can conserve the animals that are already there and then rehabilitate it. And when I'm talking about rehabilitation, I'm talking about like salmon, for example. Salmon used to be in California. There used to be salmon runs all the way into Central California, but now they're not. So stuff like that has huge impacts on productivity. That's called trophic cascades, where you remove something or impact one thing in the balance, and it's like a house of cards. The entire environment will just fall down. So we're desperately trying to figure out ways to live sustainably on the environment, with the environment, but then also maintain our animal populations and stop that mass extinction that's happening right now. That's human caused.
One last question.
All right, last question, then I'd like that out. So what? Yeah.
Okay. Well, one last question. Elon Musk seems to believe that the planet can support something in the neighborhood of 9 billion people. What do you think? Do you think that the Earth is overpopulated, underpopulated, or just about right? Give me the Goldilocks version here. In regards to sustainability, human life on planet Earth.
I don't think my words for Elon Musk are TOS friendly. So he called my entire.
Okay, well, it's an adult program, so go have at it.
I mean, he called my entire field of research that I'm getting my PhD in fiction and doesn't. It's a meme and doesn't really exist. So he thinks it's a joke. I remember that. He I don't. I'm not a huge fan. I think. I don't, again, like numbers, again, population numbers. I don't know. I don't know what the number is. I know that there has been a green revolution in the past through molecular biology in the 60s and 70s, I believe, that kind of just enabled a lot more food to be made on the planet, so that plants are basically more productive. You could actually have more plants per acreage, and then that allowed more people to survive. So, I think that we have enough room for everyone. We've got a lot of research going on. We got a lot of development going on. There's no reason to worry about population or depopulation numbers or anything like that. I think it's just kind of hysteria for no real reason. Just if you care about this issue, then try to give back and contribute in whatever way that you can. You don't have to be a scientist to contribute, but I wouldn't go around saying that we need to depopulate the world. That's just craziness.
There's a couple of that theory. All right, well, Greg, thank you very much for joining us. I will say I was very excited to hear what you had to say, and I'm cautious. Well, I got very excited when you started talking about this. I said, "Wow, this really is the solution. What's the problem? Politics? We're dead. We're screwed. Never mind." If this is going to have to pass the U.S. Congress, it's been nice knowing you. I'm glad we met before the apocalypse. Thank you. I thank you so much for. I think this is worth talking about, and I'm very glad that you came on to talk about that with us. Where can people find you? What's your YouTube channel again?
Yeah, the peer review. It's you can go there. The URL is just thepeer.review. So I've got a YouTube channel. I stream Thursdays at 6 p.m. PST, and I've had I'm working on this manuscript right now, trying to graduate. So I haven't been streaming as much, but yeah, I do that stream every week. And then there's some cool videos out there about like how we used, someone used, I didn't use it. Cool stuff like how engineered virus-like particles were able to cure genetic blindness, stuff like that. Real cool. If you think that's interesting, check out my channel.
We are going to have you back. I think there's a lot more to discuss than we can fit into one show. So thank you so much for coming on. Let's now either later this week. We haven't settled. We're trying to sort out times, but we're going to have on Jason Torn to discuss climate change. Is it really a problem and why? We've done our solution show. We may have tipped where we're going to land on the show with Jason, but we're still looking forward to that. It got pushed, so we're doing this kind of out of order. The other thing is then we're going to have on Dr. Conspiracy and 𝐓𝐢𝐬𝐿 to discuss specifically science conspiracies, why they're so prevalent. Scientists have already cured cancer and they're holding on to it because, that's how they're going to make money. And so we're going to discuss the most common science conspiracies and how and why specifically it hits those areas in the way it does and what, if anything, can be done about it. That again, ostensibly next week. Check in with us on the Discord if you want to know when. Also come to the Discord. Hang out. I don't know if you've got time right now. I'll be in the Discord in about 5 minutes after closing. So if you want to answer questions from the live chat, that if anyone wants to come in, are you going to have a few minutes for the Discord after the show? Yeah, I got bedtime for the kids, and then I'm down afterwards. Same here. So I'm gonna say goodnight to the fam, unwind the show. I will be there in about 10 or 15 minutes. I'll make sure you get the link you're already on the Discord, so we'll just be in the. Perfect. So thank you all for joining us, and thank you, 𝐓𝐢𝐬𝐿. Thank you, Sinister Porpoise, for the live chat. In fact, since Sinister Porpoise is all of us, I already thanked you 3 times when I thanked Greg, 𝐓𝐢𝐬𝐿, and everyone else in the live chat, so you're getting a little greedy with those thanks now, aren't you? Thank you all for joining us, and I look forward to seeing you when we get those dates settled. Have a good night.
All right, see you.